Myself Seth Singh, I am head of the school, Navi School, Lodi Colony, New Delhi. Today I have to share something regarding the fundamental forces in nature. And it is the experience of everyone that in one way or the other he has encounter with the force in nature. And the Greek thinker Aristotle held the view that if a body is moving, there is something external effort which is responsible for this motion. So, the cause of every movement and the cause of every change in the nature is due to force. And here, to understand the force, we can divide the forces in two parts. Some are basic forces which exist in nature and some are the derived force. When we talk about the derived forces, we are talking about the force of friction, we are talking about the van der Waals forces, we are talking about the spring forces. But there are some forces which are independent and there are the basic laws of these forces which exist in nature. The origin of these forces, derived forces, is in nature, which are described in very brief. Now, we talk about the very basic force in nature, that is the gravitational force. And all of you are familiar about the gravitational force, because things falls down due to gravitational force, thing cannot escape due to the gravitational force. The gravitational force is the force of mutual attraction between any two mass objects, by virtue of which the force which is making the things very stable, that is the gravitational force, and it is universal force. Every object in the universe experiences this force due to another mass objects. This is the force which governs the motion of moons, planets, stars, galaxy, etc. And it plays a very key role in the large scale phenomena of the universe, such as the formation of galaxy, the evolution of star and some other galactic events. And this force, we can say in terms of mathematics, is directly proportional to the product of the masses and inversely proportional to the square of the distance. To make the equivalence, here we can use a constant which is known as gravitational constant, and value of this gravitational constant is 6.67 into 10 raised to the power minus 11 Newton meter square per kilogram square, and it is universally constant. That is why we say it is constant. We can talk about another force which is also equally important, that is the electromagnetic force, and this is the force of attraction between charged particle, and it also repels the charged particles. If charged particles are like charged particle, then it is the force of repulsion. If charged particles are the unlike charged particles, then it is the force of attraction, and it can be expressed in similar way as directly proportional to the product of the charges and inversely proportional to the square of the distance. And again here for equivalence we use electrostatic constant, that is K, and its value is 9 into 10 raised to the power 9 Newton meter square per coulomb square, where coulomb is the unit of charge. And there is very important force which is known as the interaction between electricity and magnetism. When two charged particles are moving, they also produces magnetic field as well as electric field, and force between them is mu naught upon 4 pi q1 q2 v1 v2 upon r square. So, it is directly proportional to the product of charges and also the product of their velocity, and this is a very fundamental force which exists in nature. This electromagnetic force can be the force of attraction and force of the repulsion depending upon the nature of charges. Here very important phenomena is that the Faraday tried to make relationship between electricity and magnetism. That is why he has given the name that electromagnetic force. So, electricity can be produced with the help of magnet, and magnetism can be produced with the help of electricity, and that is why it is a very interesting phenomena. And one more important force is, that is nuclear force. You know that nucleus is the central core of the atom, and the elementary particles are present in the nucleus called nucleons. They attract each other, and this is the force of attraction. It is independent of charge and independent of mass also, but it depends upon the spin of the elementary particles. This force between the nucleons is called nuclear force, and it is very strong force, but short range force. If this range increases, this force disappears. So, this is the force which is the strength of the atom, and you know that everything is made up of atoms. That is why this force is very important, and it is very much natural. It exists in nature, and one important characteristics of this force is it exists in a very strong way within the range of 1 Fermi. 1 Fermi is the distance which is equal to 10 raised to the power minus 15 meter, and this attraction becomes very useful and very negotiable at the distance of 0.4 Fermi. In fact, there are the forces which are directed towards the center of the objects, and these are called force of central nature, and there are certain forces which are non-central in nature. And one thing here that is very important towards the unification of the forces. Here we have talked about the gravitational force, we have talked about the electric force, we have talked about the electromagnetic force, and in all the mathematical relations you have seen that these are the forces which are directly proportional to the product of their identities like masses, charges, velocity, and similarly it is inversely proportional to the square of the distance. So, here you can see the symmetry of the forces in nature. All the forces have symmetry, they are inversely proportional to the square of the distance and directly proportional to the product of their characteristic identities. So, this is something which is about the unification of the forces. Earlier it was the belief that electric force has no relation with the magnetism, magnetism has no relation with the gravitation, gravitation has no relation with the electric forces, but now we are towards the unification of the forces in nature. And there is very important discovery of Oersted and Faraday when they are doing one experiment to show that there is no relation between electricity and magnetism. So, in that experiment they find that electricity can be produced by magnetism and magnetism can be produced by electricity. This is something important, that all these laws governs the nature. That is why these laws are also called physical laws, and their relationship is very important to know. If any physical phenomena governed by the different forces, several quantities may change with time. And there is one thing which is very much important and remarkable, that all these forces are based on the conservation law, which we have already talked in our first discussion. Conservation laws have a deep concentration with symmetries of nature. For example, an important observation is that the laws of nature do not change with time. It can be experimented, and these experimented performed will tell their conclusion. If we are doing some experiment in the laboratory and we are repeating it, then the same object, the name objects under identical condition, the results are bound to be the same. If objects is same, time is same, temperature is same, conditions are same, then the result is bound to be same. It also happens in the nature. If something is changing in the nature, it means there is some cause, there is some physical law related to the nature and bringing that cause. Here we can talk about the gravitational force again, and there is the acceleration due to gravity, but this value of acceleration due to gravity may be different for different planets, but law is the same, that is the law of universal law of gravitation. So, here we have talked about some fundamental forces in nature and the physical laws related to the nature and the symmetries of the nature and unification of the forces. When we talk in next discussion, we will take certain observations, and for the observation we need measurements, and when we need measurement, in the process of measurement there may be some errors. So, in next discussion we will discuss about the measurement, errors, accuracy and precision.